Alright guys, so we're going to do part 2 here of going through our various methods for evaluating limits. So this next one we're going to look at, this is called change of variable. Okay, change of variable. Now, change of variable is admittedly quite challenging. This is one that some of you will likely struggle with, and that's okay. But it is one that you really want to take the time and try and get this because it's extremely important moving forward, and it's a technique that comes up over and over and over as you go and do higher level math. It's an extremely useful technique. Okay, so when you're going to use it. I mean, first off, we'll look and, again, we can't substitute x in for 0 or 0 in for x because obviously we divide by 0. But there's no way you can, rationalize this. There's no way you can factor this. And generally, you'll know to do this kind of thing because there's something quite complicated. Okay, so in this case, we've got this third root. We're adding an 8 first, and so it looks tricky, okay? And it is. So what you're going to do, though, what we're going to do is we're going to say, well, I don't like this. I don't like this stuff. So I'm going to instead say, let's let u equal x plus 8 to the power of 1/3. Okay. Now what this does is we're going to be able to replace all that stuff that we don't really want to deal with a u, so that this whole section will kind of disappear. Okay. Now you can't just do that, because we do have other x's there. You have to change all of the x's if you're going to do this. So once you've figured out what you're going to let your new variable equal, you have to go back and figure out what the old variable would equal. Okay, so in this case, we're going to say, well, what would x equal? Okay. And so if we took this expression and we isolate the x, well, you're going to have to cube it to get rid of that 1/3. So you're going to have u to the power of 3. And then you got to get rid of the plus 8, so you're going to subtract 8. Okay? So, we've done that. The next part is that we've also got that the limit is as x approaches 0. So if we know that if x is approaching 0, we have to be able to write that in terms of u. So as x is approaching 0, what is u approaching? So what we're going to do is you're actually going to replace your x with the 0. Okay. And we're going to solve for u. So we add 8 to both sides, we take the cube root, and we see that u is actually going to be approaching 2 in this case. So we know, so I should have actually, well, whatever, it doesn't matter. Okay, so we now have a new u, we can replace our x, and we know what u is approaching. So we can say that that equals the limit as u approaches 2. Take all of that stuff and say it's u minus 2 over, and this is where we have to say u to the power of 3 minus 8. Okay? So now you can see this is a lot less chaotic than this one up here. So we've really simplified it by doing this. Now, with that being said, we haven't actually gotten rid of the problem yet. Because the problem here was that as x approaches 0, we're dividing by 0. But on the bottom here now, as u approaches 2, well, we're still approaching 0 on the bottom. And that's always going to happen when you're using change of variable. You're not going to, because you just changed the variable, you didn't actually change the equation, you're still going to be dealing with that same initial problem. The thing is, we now have some techniques to deal with it, because we can actually, if you look, hopefully you remember from advanced function, how to do your difference of cubes. Okay? So we can now factor this. We can say that that's the limit as u approaches 2. And we're going to leave the top for now, because there's nothing we can really do with that. But on the bottom, we've got a difference of cubes. So that's going to be u minus 2 times u squared plus 2u plus 4. Okay. So if you haven't memorized your difference of cubes, you might want to go back in your notes from last semester and make a note of those. At this point, at the very least, you should be able to look it up and know how it works again. Okay, but with that being said, it is something that you do need to memorize. Okay. But so now that we've done that, we've got a u minus 2 on the top, we've got a u minus 2 on the bottom. So we can cancel those out, and we're left with the limit of 1 over u squared plus 2u plus 4. And now there's nothing to prevent us from subbing in the 2. So we just have 4 plus 4 plus 4. I skipped a step there. I shouldn't have skipped that step. I'll write it over here. We should add 1 over 2 squared plus 2 times 2 plus 4. So there's the step that should have gone in there. I just got excited. Okay, and so 4 plus 4 plus 4 is just 12. So we're left with 1 over 12. And that's our answer. Okay. So you can see this method, I mean, it's not, you're not doing anything that you've never done before. It really is just that you have to, think your way through it. Okay. The actual concept can get quite intimidating. So we're going to do another one here. Okay, we're going to do it the same way. We're going to look and we're going to say, well, I don't like this x to the 1/6, right? That's crazy. I'm not dealing with that. So we're going to say let u equal x to the 1/6. And I don't know why we usually use u when we do change a variable, but we do. Okay. Now, the last time we then had to go and figure out what x equaled. Oh, I went off the screen here again, didn't I? Hopefully, I can't tell. I keep doing this. I got to keep on a better eye on this, but there's everything I went over there. Whatever. So anyway, last time we had to figure out what x equaled. Now there is no x by itself here. We do have x to the 1/3 though, and we are going to have to figure out what that equals. So we're going to say, well, how can I make this into x to the power of 1/3? So we can say, well, that would be x to the 1/6, and then we would square it. Because if we square that, it becomes x to the 2/6 or x to the 1/3. Okay. And so if we're squaring that, then we're squaring this, so we're left with u squared. Okay. So we're just left with u to the 1/3, or sorry, x to the 1/3 is equal to u squared. Okay. And this is actually going to work out very nicely. The only thing left then is as x approaches 0, well, as x approaches 0 here, u is also approaching 0. So we're still looking at a u approaches 0 here. So we'll say equals u approaches 0. And we've now got u minus 1 over u squared minus 1. Okay, so this one's actually, even though I think it actually looks more complicated than the first one at the beginning, but it actually ends up being a little bit more simple than the last one was, because the factoring is a little bit more obvious here, and so it's just going to be a difference of squares. Okay, so we're going to have u minus 1, u plus 1. Again, we're going to have that u minus 1 and the u minus 1 cancel out. And so we're just left with the limit of 1 over u plus 1. Okay? And at this point, we can just do our direct substitution. So we get 0 plus 1, which is just equal to 1. And that's it. Okay? So that's change of variable. And like I say, that's going to come up time and time again. You're really going to get sick of that one eventually. But this next one doesn't come up nearly as often. It's probably one of the least common, which is good because it is also a little bit tricky. Okay, so these are absolute value ones. So we're just going to call it absolute value. Okay, and the way these work is you're just going to have to go back to what we talked about in the 1.2 video, where we talked about doing left side limits and right side limits. So what we need to do, so we're going to take our function here. So the function to begin with is x minus 3, the absolute value of x minus 3 over x minus 3. Okay, so that's what our function was. And so what we're going to do is we're going to break that up and we're going to describe that as a piecewise function. So I'm going to say f of x is equal to, and we have two situations. If x is bigger than 3, then this is just going to be x minus 3 over x minus 3. Okay, so that would be, sorry, I didn't make this thing big enough. That would be if x is larger than 3. Okay, the other situation here is that if x is less than 3, then we do have to change the sign of this. So this would be negative x minus 3 over x minus 3. Okay, and that's going to happen when x is less than 3. So what we can do is we can look at this and we can say, well, hold on a second. X minus 3 over x minus 3, those cancel out. So I'd be left with just 1. Okay, and similarly, we've got x minus 3 over x minus 3, but there was a negative in front, so it's going to be negative 1. That's right there. So as a piecewise function, this just equals 1 when x is greater than 3, and when x is less than 3, it equals negative 1. Okay. So, let's see. We're going to graph that. Okay, so we're going to go back. I'm going to use my fancy so when it's greater than 3, it goes off like that. When it's less than 3, it's going to go off like that. Oh, I kind of went a little crooked there. That's good enough. Okay. So there we go. So that's what our actual function looks like. Okay. So what we can do now is we can say that the limit as x approaches 3 from the right side, I'm just going to call it f of x because I want to write that all out, but from the right side you can see that it is approaching 1. Now the limit as x approaches 3 from the left side, so we're coming in from this way, is going to be negative 1. So because those two limits, the left side and the right side, don't equal, this is a limit that does not exist. So we can just write dne, and we are good. That's all you have to do, because there is no answer. Okay. So let's just do the last one. The last one's the exact same thing. Okay, it works exactly the same. It's just a bit more of a difficult function to deal with here. So I'm going to say, actually before I start, I'm going to say x minus, I'm just going to factor this right now, just so that we can deal with it already factored. Okay. So we need two numbers that multiply to -2, add to -1. Okay, so if they multiply to -2, let's see, so they're going to be -2, and it's going to be +1. Okay. You can always do these kind of offside things. You want to separate it. You need to make sure, like, don't go putting an equal sign there, because that doesn't equal that. Sometimes you put lines. It gets a little messy because I'm kind of out of room here, but it's okay to break things up into pieces like this. It sometimes makes it a little more simple. So anyway, so our function in this case, okay, is going to be, well, we're going to have x minus 2 times x plus 1 all over x minus 2. And this would be if x was greater than 2. Okay? If, however, x is less than 2, we're going to have x minus 2 times x plus 1. Then we're going to have negative x minus 2. Okay? So that would be if x is less than 2. So again, just like before, we go and we notice that we can reduce this by canceling those out, reduce this one by canceling those out, and so we're left with x plus 1 when x is greater than 2. And we've got negative, so if you look here, there was x plus 1 left on top and a -1 on the bottom, so you just make the whole thing negative, so it would be negative x minus 1 when x is less than 2. Okay, so that's our function. So again, I'm just going to go and I'm going to graph it. Okay, so if x is greater than or equal to 2, we've got x plus 1. So it would be 3, and then 4, and then 4 would be 5. So it's going to look like this. And then it's going to be negative x minus 1 if x is less than 2. So we're going to go through -1. There we go. There we go. So once again, if we look, the left-sided limit, so the limit as we approach 2 from the left, f of x is going to equal -2 in this case. And the limit as x approaches 2 from the right equals +3. Okay? And because those two don't equal, again, the limit does not exist. Okay. So that's it. Those are the 5 methods that you will need to be able to evaluate all the limits you see. All right? Thanks very much.